the sigma naught and the coherence. Then it's the Doppler shift, the calibrated Doppler shift when we remove all the non-geophysical contribution, and the SeaSAR cross spectra. And so yeah, you can and so in fact from these three parameters you see that it's not necessarily a direct connection to one of the retrieved parameter, which is so the KWSV you see is the well-known kinematic wind stress vector is not only estimated using the cross-section. So we are also making use of the Doppler and and the Strix information to constrain the direction. And so for the Doppler estimation, we also make use of the in fact to decompose the Doppler into a wave contribution and a surface current contribution. We invoke both the cross section and the SAR spectra through the IMAX parameter, which is a high wave number imaginary part of the cross section. And for the wave retrieval, we are also taking information from both the Doppler and the cross section. So in fact, eventually we are going towards an integrated retrieval of these parameters. So mostly the radial total surface current, the wind stress vector, the kinematic wind stress vector, and for the waves is both the swell spectra and the wind C integrated parameters like significant wave height, mean period and mean direction, and the integral significant wave height. So we've come up with this integrated retrieval, and so that means that that heavily relies on a good calibrated measurement. So we know that the cross section is properly calibrated, and the SAR spectra is also quite well constrained. We have seen in the wave retrieval that the imaginary part of the cross spectra is not necessarily only governed by wave motion. There are also some artificial phase coming from the imaging mechanism, the varying geometry during the dwell time. This is to take into account, and the Doppler, we know that this is one of the parameters that is quite hard to calibrate on Sentinel-1, but we have now a way around by using some on-ground processing using the Sentinel-1 gyroscope. And so now we can obtain a calibrated Doppler from Sentinel-1. So we hope that this will still be possible for the future Sentinel-1 CND and the next generation. And so there was also some clearly gaps identified on the model function. So especially for the wind stress and the wind direction. So there are clearly a need for some campaigns to measure the wind stress direction and the wind speed direction compared to the observed wind streaks that we see on the SAR image, and derive some proper model for the wind direction, because it has been acknowledged that the wind streaks are not aligned with the wind direction, as some people can believe. And so it was also acknowledged that the SAR spectra is not available for all modes of Sentinel-1. Like for example, the IW mode is there is no SAR cross spectra at the moment for IW mode, and so there's been a clear recommendation to have that available. So there are ongoing projects to come up with this product, but then it should be as soon as possible distributed to the user community. And there have been also a strong recommendation on possible reprocessing of NVSat and Sentinel-1 in a consistent way, since they are especially for the Doppler and the cross spectra, there have been several like tens of different versions of the evolution of the processor, and there are as many different type of products, and so there is no continuity in time of the existing archive, and so there is a strong recommendation to reprocess at some point at least the Sentinel-1 with the latest processor, at least for the level 2, and this is mainly for the providing some global wave model reanalysis that really rely on the assimilation of this information. So yes, I think that yes, really the important message is to realize that we need to have an integrated and multi-scale also. So we discussed that we start with probably a large-scale retrieval, and then we invoke that as a first guess for higher resolution retrieval. And so to have this integrated retrieval and to set up observation campaign to measure what we need to close the gaps in the geophysical model function for the retrieval. So that's an important message, Marcel. Yeah, the classification. In fact, as you see on the left of this graph is it's called feature, but it's something that have been demonstrated that we can now classify the SAR image according to different feature, and this is the first step for many different retrieval, especially for the atmosphere signature, but can be also for the oceanic signature. No, this is a we have the machine learning and we have the Paco Lopez processor. So you see, it's a multi-scale processor that we have set up for Harmony. So Marcel, do you want to add something on this beautiful Miro for the summary of the session?
Yeah, no, I think what we have here is basically describes the processing that we can do if we really work out every product of Sentinel-1 with a little bit of external data. And what we didn't describe here is the multi-sensor synergy, which of course puts an additional set of constraints on all the parameters. But yeah, we already have SST indeed, but in that sense, so for example, the altimeter can provide additional information on the SARs on the spectra. Also, HS scatterometers can help us with the wind, the low resolution input. So that's what I think.
So from that we can hand over to the Doppler people if they want to add something on this or on their session in general or on the Miro. Do somebody from the Doppler session wants to add something on that? Yeah. And on the recommendations? Yeah. So I think it's time if you want to. How do we do it? How do we do the Can you connect to the WebEx or?
One thing, maybe we can make this available to everybody.
Probably easiest. Do you have slides or do you have something in the browser? I have a couple of slides. Email them to me.
What? Yeah, we'll make this diagram available to all of you if you want to add your personal touch to it. And of course, this is a simplified view because when we have only one line of sight SAR measurement, when we get multi-azimuth measurements like with Harmony or eventually with SeaSAR, then we can do more retrieval, but there are some limitation when you are having only a side-looking radar. So if you have question on some details on that, you're welcome to contact us. Contact Marcel. the Miro guy. So what Miro stands for?
Multi-scale integrated retrieval for the oceans. Nothing to do with the website.
So the website took the name of this beautiful idea. So by the way, there was also a strong recommendation from the people around at UNIS that we also provide information on wave in ice from Sentinel-1. So this is also one of the recommendations that we should work on for the wave retrieval. Yeah.
Waiting for it to arrive.
Speed of light is not what it used to be.
Has to go through a couple of government stuff. Needs to be scanned. Yeah, you can start down the slides that come as soon as possible.
In fact, I don't really need the slides.
Okay.
I can.
Yeah, I'll put them on as
Yeah,
soon as I can.
when they appear, I tell you. So we didn't do too many recommendations, but I can start with the most important. The most important, you will be very surprised to hear that I think we should go for a multi-scale integrated retrieval for the oceans. That includes the south. I think it's the previous diagram reflects one of the recommendations. So we really go for that. The second, not in order of importance, but is that we are making these very nice observations, or trying to make these very nice observations with lots of issues still, but we need something to use as a reference, and we need something to compare with. We need some kind of ground truth, so we need some kind of long-term sites that we can use to validate and calibrate the observations that we make, and also to interpret, because even the question of what is the depth of the surface current that we measure is not it's a bit not unanswered. And even if we give an answer, you would like to show that it's actually true. So I think that's an important thing, and that we need Cal sites for the surface currents that we can retrieve from here, but in fact for all the ocean products that we are generating. Very good. So I'm here. And then the third one was that we are developing, or different people are looking at, are doing empirical models, some people are doing theoretical models, and that we should try to do that as a community, to have a shared effort. That means that we put it somewhere where other people can use it. And for me also, that we need to try to combine the best of the empirical models, which are self-calibrated because you are using data, with the best from theoretical models, which probably can handle things that an empirical model will never be able to handle because of lack of training data. And then there is one which I don't really understand because we wrote it this morning, but which is we should agree on what is contributing to the Doppler that we see. So we have currents, and then we have a wave Doppler, but the wave Doppler may have different components as well. So we need to agree on that and agree on the interpretation of the wave Doppler. But that's what I said before. These are general recommendations we had, and then we spend a lot of time in the breakout looking at Sentinel-1 and the problems that we have there, and it's super nice stuff. And what we think we have is some of the problems that we have in Sentinel-1 are related to how the requirements for Sentinel-1 are formulated. And Sentinel-1 is not designed to provide good data over the oceans. It's really designed to provide good data over land. And a lot of the requirements are there to make the people happy that do interferometry. So we have to see what is the effect of those. So we can see effects. For example, we are seeing that there is a temperature correction in the radar to keep the beam pointed, but that happens in a way that it's very bad for the people trying to look at the Doppler estimation. And the exercise would be to try to understand where this requirement came from and what is the impact not only on us, because we can see that, but also to understand what is the impact of having the requirement as it is or not on the other users, on the people doing interferometry. Because I suspect, and Muriel from ESA who already left, she agreed that we probably, the system is doing things to try to correct for tiny errors that nobody cares about, but which are causing a lot of trouble to us, right? And if we could really show that this is the case, and then we could ask ESA, please don't do it, because nobody cares. The satellite is doing things, and nobody really benefits. So that, but that requires effort, because there's lots of people that agree, and even the people at ESA who understand this, they probably agree. But to get from an informal agreement to a decision of changing something, that's a process. So we need to push for the process. And same for attitude corrections, is the same problem. So Sentinel-1 is probably trying to correct a lot because somebody wrote a very simple requirement, which probably was not needed. So it's the same story. We should try to understand what was the requirement, why, and then pedagogically go to ESA and say, you don't really need that to do what you're trying to do for the purpose of interferometry, which they don't. And then we have Sentinel-1 XG coming. And in Sentinel-1 XG, while we are here discussing the problems that we have with Sentinel-1 first generation, I know that the next generation is going to be much worse if we don't do anything urgently about that. So I think the urgent action is that this needs to be evaluated. We should as a community know what are the requirements, because I know that then they come back and say, yeah, we didn't have requirements. So we need to know what are the requirements and communicate them and follow up on that. So there should be some study at ESA to evaluate what is the impact of the decisions they are making. We should have something to say about the wave mode. Right? There is the machine that is coming has endless possibilities, but if we don't do anything, it will run the wave mode that some engineer at Airbus or at Thales thought makes sense. So we need to really think about that and formulate what we want, and then try to get it. And then, like in the previous one, reprocess the level 2 Doppler products with what we have now. So go back into the data archive and reprocess the data. I think that's a no-brainer, but should be done. And then the last is we see there is lots of people doing nice thing to process Sentinel-1 Doppler. But if you are a new person into that, and even if you're not a new person, you are probably a bit lost. You don't know what to do, what to use, how to do it. So it would be nice to have some kind of community repository with resources and with a bit documentation of how to do it. Where do you get the data from? What do you need to apply to it with alternatives, so that people use it more, and in this way we can promote the use of the Doppler. And that's what I had in the notes I have. If I forgot something, you remind me. No. And if you
mentioned that we have a nice concept for our paper. We are way ahead of many.
Yeah. Yeah. So the recommendation for the rest is that you hurry up, because if you don't, if you're not careful, we will have a very nice paper before you do. Yeah, it's not really a recommendation, but we have a setup for a paper. I hope everybody has it. At least we have tasks. Yeah. I know. I may have missed it. I may have missed it.
For you, how essential is high quality in situ observation?
I put it in the previous slide. Yeah. So that's one of the recommendations that we have, is that the thing we need to establish something. And I wrote it myself as identify or establish, because maybe we have stuff and we are not aware of them, but we should know where to look for the in situ data we need. And so that thing is a strong.
Buying them already for skin from
Yeah. Now the question is, the identify part was because I'm sure there is instrumentation out there that some people are aware, some people are not aware of. So there is probably already some stuff that we could use. But
as we discussed last night, if you're serious about doing this, you need to design experiments. It's insufficient to just go back in the bowl. Try and do something. Just make a mess.
Yeah, I totally agree, Craig, and I'm happy that you still think the same today.
I think it's essential. We have a 3-year horizon planning those kind of things. Yep. Something that needs to be done. I don't think we can mess around. Harmony is going to be complicated. We don't have infrastructure. In terms of verification and validation, so we need to think now about putting that infrastructure in. It's 20 to 30 million euros. It's a big international project. It demands buy-in from many people. It needs a very strong leader, good coordination, and access to professional oceanographers that know what they're doing in terms of moorings, instrumentation. But I think this is an essential experiment that should run for 3 to 5 years, and it would be really focused on getting to grips with SAR imagery, so that we actually really do understand what the hell we're looking at, because it's tantalizingly beautiful but extremely complicated. And I think it's the corollary, if you like, to what Justin was showing yesterday or the day before, I can't remember now, when we were looking at all the wave mode data. The complexity is enormous, but in order to make sense of it, now we need to think about having a properly defined oceanographic experiment or ocean atmospheric experiment to get to grips with what we're seeing.
Anyone? More questions?
Just more a comment and a question on your next recommendation on Sentinel-1 next generation. So it's just to say that before we get to the Sentinel-1 next generation, we have Sentinel-1 C and D to come. And so even though it's certainly too late to have some new requirements on this unit, there are certainly some impact study to do on how to better calibrate this new Sentinel-1 C and D based on the fact that they will be a little bit different at Sentinel-1 A and B. We know that, and so that's also something to prepare for. And And so even though we don't put new requirement now, we can still try to assess how we can things that can be done to optimize this new the two new Sentinel-1 to come. So this is a clear recommendation to ESA to consider this analysis and this performance estimation based on the modification that are on Sentinel-1C and D.
Are we writing this up? Yoni, are you taking notes of everything, or?
No, not necessarily getting notes of some of these detailed comments.
Okay, so we have to put them back. I think somebody's coming now. What's the next? Now, what comes now? Winds.
It's not here yet.
You can start without it.
All right.
Put it on when it comes, if it comes.
So we've been discussing the different recommendations, and obviously some of them are going to be redundant with respect to the one that you've already heard. One main recommendation that we have from the wind community, because so far we are using a lot the sigma knot from the copole and from the crosspole. So the main requirement for the wind applications would first to start to have higher calibrated sigma 0 for both the co and the crosspole, which is really something that is being needed. I can go into a bit more details for this as it's coming. It's a PDF issue.
You are talking about improving the calibration or the retrieval?
Improving the existing calibration. Okay. So to improve the calibration, because we see, okay, this is for several reasons. But first of all, we see that for the VH measurements, which of course are the most sensitive to the presence of noise because it's higher, we need to have a better signal to noise ratio for this specific channel. But we need also to have a better noise accuracy and a better the way it's annotated in the products, because sometimes we see that we see some discrepancies not only for the VH channel but also for the VV channel. So this is really something that has a huge impact when we start to look and start to derive any GMF afterwards. And it's even higher when you start to have a look at the impact on the wind resource assessment that you're going to estimate from this data. So you can have some scalloping and some subsource to subsource jumps that are happening in time. So basically, I think we need to be more stringent in the constraints that we are going to require for the stability of the calibration, stability over time, but also the homogeneous stability calibration throughout the rolled products. So in swath and in azimuth, which is not always the case. I'm not saying it's catastrophic, but we didn't have yet any real stringent constraint on the product to product. It was more statistical constraint, but we need to have something which is also valid for instantaneous products. For each of them, I mean. I'm not talking about the calibrated Doppler. It has been widely discussed already. talking about the reprocessing, so we talked about the calibration, but of course, if we manage to have an improved calibration, and of course, the calibration is increasing on a day-by-day basis, thanks to the work that's performed also within the MPC. And but since the calibration is improving, the old data is not benefiting from it. And if you want to start doing some analysis over the full archive of Sentinel-1, it would be, of course, much better if you could have had a overall reprocessing of that data. I know it sounds enormous, but it's possibly possible to imagine starting with the so-called supersite that everyone is talking about. That can be used for several purposes, whether it's for and for various reasons. For the motivations are the presence of, let's say, source reference data. If you want to have validation campaigns, because this is also a wish, and typically this is what is being done for the tropical cyclones, where we are taking care of trying to use the validation campaigns and the flights from the SFMR, but there are maybe some other possibilities of additional campaigns that would be possible. So there was a requirement to support field campaigns, not only for tropical cyclones, but in general. And yeah, also one of the motivations could be not only for the presence of reference data, but for to test the impact on possible applications, such as a wind resource assessment. Also, there were several a lot of motivation in having access to that better identification of non-wind related signatures. There's been widely discussed whether it comes from the classification, whether it comes from the segmentations. There are already a bit of it in the ESA level 2 products. For instance, there's the bright target, a bit of a sea ice, which could be, of course, improved. But of course, we've talked about a lot of it in the methods session, and this would really benefit, I think, to this product. This could be included inside in a way. So that's to be thought of. Also, of course, today, most of the variables for the wind, they are estimated from the GRD products, but we've seen that if we want to have this combined all together, wind inversion and then wind, wave, and current, we need to be starting from the SLC products. And talking about the SLC, we need to get rid of any ad hoc filtering that is present and is actually not necessary. So there's a requirement to use the SLC data and to have a clean processing as much as possible. And the third one is to better combine, as we said, all the wind-related SAR observables. So, but not only for the wind, but to look at the interdependency for the wind wave current retrieval. And finally, but not least, I'm sure you've heard about the requirement to have a better intercalibrated products between the different SAR, but also between the SAR and the SCAT. So it is important that even if we have different instruments, we manage to measure the same thing. And I think there is some work to manage to define some best practices, some benchmark to make sure that in the end, we manage to retrieve winds that are consistent between those different ones. And the last bit is just to discuss what's going to be the organization of the white paper. So, well, basically, I don't know if you guys how you have discussed this, at least for the waves and the current part, but there is a lot of, from the initial plan of Knut Freud in the overview, there was a whole part split in the different SAR observables. And I think all these different SAR observables, I mean, they are not necessarily bound to a specific thematic because they are useful for all the three of them. And so we could think of a common description of these three different observables and then tackle the different specific inversion one at a time for the wind inversion and wave and currents, and then have this other chapter on integrated parameter retrieval. So that's, of course, to be discussed with you guys to know what you feel about organizing this.
You want to have a separate paper?
No. I mean, do we need to have one separate paper for each them, or a common one where, because describing the SAR observables, it doesn't need to be done for each of the wind, waves, and currents papers. I don't think it makes sense. What do you think, Fab?
Johnny.
Or Johnny?
Well, I can at least add one. So I can add one point to it. It's you may have that question, but there is a final date.
Yep.
So whatever you do between the question and the final date, I will not try to tell you that, but the final date is December 2023.
So Ralph was saying that in their group, they try to split the contributions and they've put some intermediate dates. And they said,
I find that to be very, very correct. I mean, if you just say that the plan is December 2023, you may have difficulties if you don't have some milestones on that way.
no, of course. Oh, well, yeah. To start with the time, the time we need to discuss the content. But do you, okay, maybe this is not the most important, and we can keep on discussing the plan afterwards, but I don't know if you have some more comments on the general recommendations.
Just a question. So what you're saying on the routine production of Optima's SLC is so you're recommending ESA to produce a different SLC than the one they're producing now.
Yes, the idea is at least to start considering alternative processing.
No, because in fact, there is already a routing production of internal SLC for the level 2 products of Sentinel-1, but it's just not distributed or not, I don't know, not available. But so are you considering a different one of this internal SLC or?
No, so you mean the SL2?
Yeah.
Yeah, no, it could be the SL2. It's just that we need to make sure, we need to review the processing to make sure if the SL2 is what we need.
So it's very nice to see some of this. It's not so straightforward, but there's some commonality between what you're saying here and what we discussed in the future missions breakout. And one of our conclusions, which we'll go through tomorrow, our recommendations, is that after talking to Nuno Miranda, who's the mission manager for Sentinel-1 and Roselle, we will plan to try and run a dedicated SAR Ocean product development workshop in 2024, because we need to reconnect the users and the experts who are processing SAR back with what we've got in our archives. And if we're going to start moving towards the open ground segment where more things are possible, then there's opportunities here to think about how we might go about addressing some of the issues. I can't say we can do it, but at least what we need to do is to sit down and make sure we understand clearly what is required. So radial Doppler products, SLCs, this kind of stuff is where we're at. And also to try to make sure that at that workshop we can pull out the knowledge. I mean, one side, every time you look at a SAR image, it's great, it's a PhD, fine, the nice ones at least. But we need to find systematic ways of extracting the knowledge information that we can feed to operational systems so that there's a better uptake than that we have today. Despite the fact that we've got products in CMEMS, clearly it's not how we would like this. So there is some work to do here collectively, because I think our community is dwindling It's not a big community, and yet we have a lot of SARs coming, and we're still grappling with some of the fundamental electromagnetic interactions with the sea surface, as demonstrated by both the Harmony mission and the SeaSAR missions. So we have some work to do here, but it's good to see that commonality.
I think being able to provide reprocessing of the data with homogeneous processing, I mean, it really is something that a lot of people are waiting for, and I'm sure it will increase a lot the uptake. Yeah, Ben?
So you, for the top line, are you thinking of actually classifying, removing the bias, you know, the other signatures, or actually identifying them? So identifying, this is a sea ice, this is surfactants, along with this is wind.
I think it's good to let the data that it's inside the product, but if you have the information to provide, and if you know what it is, to tell the people what it is and where it is. So I don't think it's good to remove that data from the wind products. We can just mask it out if we, masking out, had some additional masking information, some segmentation information to tell the people, for instance, where it is. So
Well, I guess I'm suggesting is actually identify what else is in there as part of your product. So, for example,
explain? Yeah.
NOAA produces a wind product at the sea ice at the marginal ice zone. Well, they don't identify where the ice is. They may remove it from their calculation, but if they said, oh, this is ice and this is, you know, open water, that would be really useful. And it would be useful for interpreting coarser resolution imagery and so on.
Yeah.
So that, I guess I'm suggesting to actually, you know, derive the wind product without bias, without the bias of these other features, for sure. But also, while you're at it, instead of masking them, to actually think about including the other features as a classification product.
Yeah, I think it's a really good idea. What was the intent?
That was the intent?
Yeah. And I mean, in the end, if you think about it, it's not about only knowing that it's ice or knowing that it's rain. It's of course important, but for the purpose of wind only, it's important to know that it's just not wind. And this is something that we start to produce some, let's say, what we try to call some quality flags or some rain flags. But if we have all these additional observables that we manage to combine, we should be available to have a better idea of whether they are satisfying their Bragg scattering hypothesis. And if they don't, then it means that probably this is not Bragg scattering, so it may be ice or rain, and this needs to be put also, I think, inside the products.
So I would even extend that it's not only identifying the non-wind related signature, but it's also identifying all the signature that we have in the SAR image. So it could be the internal waves, it could be the oceanic fronts, it could be, in fact, everything that is possible to detect and classify now has been shown by several studies this week, and then it can be used for different people working on I don't know, on ocean current, on sea ice, on wave in ice, on wave in open ocean, on internal wave, to easily constitute a large database for their analysis, because it has been already classified for a general purpose. So I think it's mutually beneficial for many applications.
No, I agree with you. For instance, we know that there are already a classification of all the wave mode that is being done and that we use enormously. Every time we try to do some calibration and we look at the quality of data to know what it is actually pure swell or that it is potentially polluted by these other classes that you mentioned, it is extremely useful, but just to build on a data set that is going to be trustful. So yes, I agree. Even just to provide the data that we have right now and to put it, to make it available to everyone, it would be super useful. And then with the fact that there's going to be more work and the ability to provide not only classification but segmentations also for the white source data, I think that's a goal that should be targeted. And especially because I was thinking about it when we were doing the sketch in Mayor, where you put all these features as, let's say, intermediate inputs, but actually we should start to consider them as outputs of the processing. Thank you. No other questions?
If no, the last group to report would be Sea Ice, Anton.
Yeah, thanks.
Try to download it. Or can I?
You can just start presenting.
No, but no.
No?
Need to download it first.
Then the file, save a copy. Yeah. Thank you.
Yeah, of course.
Yes, I know I'm between you and the restaurant, so I'll be short. We have just one slide. We had a lot of recommendations, so I picked only some, maybe main recommendations, and again grouped them into these three topics. So for sea ice drift, we need the high resolution Lagrangian ice drift product, as it can be used for many applications. And we also really need instantaneous ice drift from a Doppler shift, either from Sentinel now with one component, or with Harmony with two components, or maybe with the SeaSAR if it flies. For sea ice, we need to use multi-frequency and multi-sensor and multi-temporal, and all that is available. We have tons of data, and we just need to find a good way to utilize that. And the good way is to use machine learning, but not just a black box. We should start using physics-informed machine learning, which include some constraints based on the physics of sea ice, of the sea ice and atmosphere interactions, and so on. And then eventually from this machine learning, we need to move to forward models to be able to better inverse these models and to have some physical properties of sea ice and snow on top. That should be backed up by in situ campaigns. And as there are more and more different electronic components that are really cheap, we should deploy more buoys that can measure more things. And a recommendation for space agencies is to publish satellite acquisition plans in advance, so that in situ campaigns can be dedicated and done simultaneously with observations. So these are all recommendations for development of methodologies, and these are the recommendations for how it can be applied. So sea ice drift can be applied for model validation and for assimilation also into models, and for alignment of multi-temporal and multi-frequency and multi-data, so that we can use both ice drift and ice type together. And then we, with this machine learning and multi-everything, we want to achieve robust sea ice type classification in all seasons. So far, it works in different regions and in winter mostly, but I think it is doable to have a good classification everywhere. And then yes, we need to move towards operational navigational support, because a lot of the efforts end up in scientific papers and are never used by captains, but that should be changed. For in situ, we are moving gradually towards studying smaller scale processes, because yeah, the larger scale are already more or less understood. And then in situ campaigns should be adjusted for that. And yeah, as I said, it should be mass deployment of buoys. Eventually, it's quite important to keep up with open science, to publish, to have DOIs, to share knowledge. Yes. And instead of thinking about a white paper, we did a fun exercise. We created a sea ice type nomenclature. In addition, or actually to replace what everybody is using, because so many institutes or so many scientists, so many different ice types. From now on, we will use this nomenclature once and forever. Thank you.
So I don't see the wave signature in sea ice in this nomenclature.
It's just a very small font. Yes, it's here. It is here. In fact, we need a third dimension to this.
Because I think probably include the ice in the wave section or the wave summary recommendations that we did not put in here.
Okay.
But there is definitely some overlap, and yeah, there are more dimensions to this ice nomenclature, including roughness and waves and melt points and so on, which are not reflected here. Thank you. Yeah.
The mic, yes. There is this boundary between the open ocean and the sea ice area coverage, which is the marginal ice zone. It must be treated somewhat as that boundary that it is. Did you specifically discuss that in terms of the demand that basically has of extra need for both observation, perhaps, and also the complication that it is to do observations in the marginalized zone?
We did discuss marginalized zone, but not specifically in context of many different other retrieval methods and applications. And yes, it may deserve a specific attention because, yeah, it's a laboratory itself.
Yeah, you're right. Yeah. Okay, baseball, you ready?
Yeah.
Is this two things? Does this match the WMO nomenclature?
We have checked against the WMO nomenclature. It doesn't match exactly the layout of the table, but it includes almost all the ice types from WMO. The advantage of this one is that it has a hierarchy.
Right.
And we don't always have to use all types, and we can choose at which level we want to stop.
So can you go back a slide or two about the, so ice drift, multi sensors well, it would be pretty nice to combine sensors. So let's say Sentinel-1 with RCM, for example, and to make a uniform, if you had enough coverage, you could potentially make, like, say, a one-day drift product instead of a uniform drift product for 1 day or 2 days. That would be really useful for modeling, I think.
Yes, I totally agree.
So
I cannot agree
the
more.
challenge is, combining, well, you can combine RCM with itself or Sentinel-1 with itself, but a challenge would be to try to intermix the two sensor collections together. And then to make it even harder, you could maybe throw in L-band at some point. So how to do that is, I think, pretty challenging. Steve Howell in Canada said it was really hard to mix sensors, but you're going to get more coverage and more a shorter time temporal sampling of ice drift.
Yeah, I think Joa Karvonen brought up, so FMI is already doing some of these things because the coverage of the Baltic Sea is not quite to the level where we like, so they actually do combine RCM and Sentinel-1 in their ice drift and ice type products.
Yes, and as I said, it's just some of the recommendations that we probably find to be the main, but there are many more that will be, summarized in the report for ESA. Okay, thanks a lot, and I think we are done.
Thank you. Oh. That's because the chat is somewhere deep hidden. Oh, there we go. Well, let's start with this one. Do we have any specific recommendations on ROSE-L?
Specific recommendation is that there should be not too large time difference between C-band and L-band acquisitions due to misalignment that is caused by ice deformation. Other than that, to launch it ASAP, that's the requirement.
Yes, then there are two that I think are for previous groups. Just a comment, Fab, you forgot to mention inside synergy, non-local, is really important.
Goes back to what you just said, Anton. There shouldn't be too much of it. There shouldn't be too much of a time separation between Sentinel-1 C-band and ROSE-L band. Did I understand that? Yeah. And I guess we know that today, don't we?
They will fly pretty far. I can't give you the exact figure, but the intention is they will fly very closely together.
Okay, so
it's less than a minute.
less than a minute. Less than a minute. It's done. It's done.
But look, I mean, let's be clear. You will get today. To the best of my knowledge, you will get today Sentinel-1, and then pretty soon afterwards, you will get the ROSE-L over exactly the same area. So you will get all the wave mode, and you will get everything the same. So you have a dual frequency SAR system in that sense. Now that needs to be okay. They're still working towards this, and things change. But that's our understanding, Martin and myself today. I don't know if there's anybody online from ESA. And we checked also with Nuno this morning, who's the mission manager, and he seemed to think that was also the case, but maybe somebody else is there. I don't think so. So for the time being, that's where we are.
Anyone from the waves or wind or Doppler to comment on Roselle?
No, I think I was going to reply to the question that he asked for me, but no, for Roselle, I think we just recommend to continue to have this wave mode and the acquisition of ocean current, because we expect that the L-band will provide an even easier way to get the ocean current from Doppler, and so to have good requirements on the Roselle Doppler. But for the question about the inside synergy, non-local. Yeah, in fact, yeah, maybe from what I understand is in the Miro we were still trying to make an integrated retrieval using all the observation that we have at the same time from the same SAR observation, but we can also make use of non-local information from, for example, when we do the swell tracking, we have some prior information on what we should expect in any new SAR observation, and so we should probably make much better use of this a priori information in the retrieval. So this is clearly something that we should consider. And also that was something that was maybe not so clear in the Miro, but in fact there was a link between the wave spectra and the surface current gradients, and so this is also non-local, and this is when you estimate the wave spectra over a large swath image. You can derive some information on the ocean current gradients, because the ocean current gradients are the one that create a curvature on the wave propagation rays that you can extract from a grid of a wave spectra over a wide swath image. So this is also, but this was included in the Miro.
Anyone else would like to address anything that's been put on the chat by online participants?
So maybe the people can, maybe the people that is online should also be made aware of the fact that we are starting 9 o'clock tomorrow and not 8:30, if that is something that they have sort of not discovered in the updated program.
Yes, online people, be aware we begin at 9 a.m. tomorrow. We are going to go through the 4 remaining groups and their recommendations.
Yeah, maybe one of the recommendations regarding the Roselle is the fact that there are already a lot of potential collocations between Sentinel-1 and Roselle, and I don't think they've really been, not Roselle, sorry, but the L-band Japanese SAR ALOS 2, and there's hardly been a lot of collocations in between the two and study of the different sensitivities of the two sensors. And I think in the preparation of Roselle, it would be really needed to be doing such a study, and that maybe ESA proposes a bit of a work to be doing so. Or maybe I'm mistaken.
There is an ESA-JAXA collaboration which has 26, now I might be a week or so out of date, but I think 26 supersites. A large majority of them, I would say, are sea ice ones. and where they've tried to do as simultaneous observations as possible. So Sentinel has also extended their flight path in specific location north after Sentinel-1B got decommissioned. So there are a lot of
But
data
is
that's
it
been collected.
is it only over sea ice?
No, not just. There is, yeah. Nope, no one knows. There is over different phenomena. I don't know how much would have been over waves or winds, but there are subtle deformation and sea ice. And Johannes, do you know more?
I mostly know the sea ice imagery, but there's quite a lot of test sites
Yeah.
that we didn't use because we didn't have any sea ice in the images. So there's
Okay.
Yeah, no, there's certainly a lot of open water, but yeah, 26 super sites in collaboration between ESA and JAXA, where they've been acquiring data since 2018.
Okay.
So you should look into that data set. It's very expansive.
If you can, we can talk after But the comment is not only on the fact to have collocated data, because I know also, for instance, that ESA is communicating when they are making triggering acquisitions of tropical cyclones with Sentinel-1. They provide that information to JAXA, and they are performing joint when they can acquisitions of tropical cyclones, and L-band is supposed to be very useful for that purpose. But it would be useful to try to see if we can already start to analyze the existing L-band C mode, L mode, and to see if it needs to be revisited, especially since we have a lot more acquisitions of such events. So that's more like a general comment for future preparation activities.